Hello everyone. In this part of the lecture, I will try to explain about descriptive statistics. In a previous lesson, I already described that data exploration divided into two parts. First, it's descriptive statistics, and the other part is data visualization. And in this particular one, I will describe deeply. No, I will talk more about descriptive statistics and some basic thing that you need to know about that. So descriptive statistics referring to a study of the aggregate quantities of the data set. So we want to squeeze the information in a very few numerical values. And it can be broadly classified into univariate and multivariate exploration depending on the number of attributes. So if you're familiar with mu or sigma or rho or R correlation, you might not need this part of the lesson. But anyway, so in general, descriptive analysis covers the following characteristics of the sample or population dataset. So characteristics of the dataset is the one I wrote in the left part, and the measurement technique are the one on the right part. So the characteristic of the dataset are divided into three. So there is center of the dataset, spread of the dataset, and shape of the distribution of the dataset. So this 9 stuff is basically the only thing you need for descriptive statistics. So in center of dataset, we have mean, median, and mode. So for the spread of the dataset, we have range, variance, and standard deviation. And for the shape, we have some kind of symmetry or skewness or kurtosis. But for this lesson, I will talk more about these two parts, the center and the spread of the dataset. Okay, so as I said before, descriptive statistics is generally divided into two parts. So we can have univariate exploration if you only consider one variables, and we can have multivariate exploration if you consider more than one variables. So in univariate exploration, basically exploration that denotes analysis of one attribute at a time. So first, let's talk about the center of the data set, which is mean. So the mean is the arithmetic average of all observations in the data set, and it is calculated by summing all the data points and dividing by the number of data points. So as you can see here, for example, I have this data 1, 2, 2, 3, 4, 5, 5, and 8 is the number of the data set, so I just add everything together and divide it by 8, and I got 3 in that value. So 3 is the mean of this data set. And in addition to mean, we also have median. So median is the value of the central point in the distribution. So we want to take the central point of the distribution. And but before you do that, you need to sort all the observation from small to large, and then you select the middle point. So the data can have odd or even number of points. So in case the data has odd number of points, the midpoint observation is just basically the median. So because it's odd, you can easily find the one in the middle. So if the data split by 2, half here and half that, the one in the middle is the median. And in case the data has like even number of data, so the average of the middle two, so you take the middle two and then you take the average, that is the median. So in case this one, I have 8 data points, and so I take the average from the 4th and the 5th elements, which is 2 and 3, so I get the median is 2.5. So that is the median. And lastly, we also have mode. Mode is the most frequently occurring observation. So in the dataset, data points may be repetitive, and the most repetitive data is the mode of the data set. So for example, in this case, the data with values of 2 has like this 3 repetition here. Okay, so because this is like the most frequently occurring data set, so that is the mode. So for this data, the mode is 2. And now let's talk about the spread of the data set. So before we talk about the center of the data, but now let's talk about the spread. So the first thing that you need to know about the spread of the data set is range. So the range is the difference between the maximum value and the minimum value of the attribute. And it is very simple to calculate, but it also has shortcoming, like what if there is outlier. So if there is outlier, so the data is this big and there's like one outlier, this one, the range will be that one, the big one, and that is not that good. But again, to calculate range, we just choose the smallest element and the largest element, and we take the difference, and that is our range. So in our data, the range is 4. And next is deviation. So the variance and standard deviation measures the spread by considering all the values of the attributes. So deviation is just a simple measure as the difference between any given value and the mean of the sample. Okay, so to calculate variance, let me explain a bit. So first we take the mean of our data, so 1, 2, 3, 4, 5 until 8, and we get the mean of 3. This is the same as what I've explained before. And after you get that, you reduced every single element by that value. Okay, so this one minus 3, and so on, and then you get this value minus 2, minus 1, and so on. And after you get those values, you take the squares of them. So you square each one of them, and then you add them together and divide it again by the number of points, which is 8. And after doing that, you get these values of 2. Okay, so first you find the mean, and then you subtract all the data points with that mean. You square them because you want it to be a positive number, and then you divide it by the number of data points, which is 8, and that is your variance. So in our case, we have the data points, the variance is 2. And if you want the math formula, you can see here. This is the math formula for the variance. So in addition to variance, we also have standard deviation. So standard deviation is basically just a square root of variance. So if a data set had a high standard deviation, that means the data points are spread widely. So the bigger the number, the wider the spread. And low standard deviation means the data points are closer to central point. So for example, this one, so this is just a graph in general. So the mu is the center point, and this sigma is the spread of the data. So the bigger the sigma, the more spread the data. So for normal distribution, about 68% of the data points lie within one standard deviation from the mean. That's just an example of normal distribution. And that is basically what I want to say about univariate exploration. And now what about multivariate exploration? So multivariate exploration is, again, the study of more than one attribute. So we talk about more attributes. And if we want to talk about the center of the data, we want to talk about central data point, basically. So data with multiple variables can be expressed in multi-dimensional Cartesian coordinates. And yeah, the central mean point may not be an actual observation, and it will be a hypothetical data point. So for example, in our iris case, we have 4 observations: sepal length, and width. Oh, sorry, it's petal width, this one. And we can take the mean for each one. Okay, and that is our center of the data. And this data might not be in the data itself. So we can take the mean for one each, and then we put in a coordinate like this. And in center of the point, it's not common to talk about median and mode because yeah, it has more than one variable, and it is least likely for them to have like a nice median or common mode. So it's less informative, these two parts. So when you talk about multivariate exploration, you might want to focus only on mean. And the variance also works similarly, so I will skip that part. And what I want to say now is about correlation in multivariate exploration. So correlation measures the statistical relationship between two attributes, particularly dependence of one attribute or another attribute. So the thing is, what I want everyone to note, I guess I've said this in a previous lesson, that correlation between two attributes does not imply causation. That is, one does not necessarily cause the other. Okay, so let me describe this with this fun example. So in summer, it is well known that as summer days moves, the sales of the ice cream also increasing. But as the summer moves, the number of shark attacks also moves. Okay, but the thing is, ice cream sales does not cause shark attacks, and shark attacks does not cause ice cream sales. But if you see these two data, they're pretty correlated. They're close to each other. So one go up and the other go up. So the data are correlated, but there is no causation. Okay, so this is very important. Two data can be correlated, but has no causation, and that happens pretty frequently. So be careful with that. Make sure you know what causes what, and make sure you know what correlate with what in your data. So the correlation can be expressed by this R, and this is called the Pearson correlation coefficient, which measures the strength of linear dependence. So correlation coefficient may take value between -1 to 1, and if you see the scale here, the value of R, which is like from 0 to 0.3, is considered as weak. Either it's negative or positive. And up to 0.7 or -0.7 is moderate. And for the one closer to 1 is strong. So this is just a guideline. So there is no strict rules for that. But in general, as the closer it is to 0, the weaker it is. But the closer the R values to 1, it's gonna be strong. Oh, sorry, I should write positive, positive, positive here. This is not negative. This is positive, and this is also positive. My mistakes. And so if you want to calculate Pearson correlation coefficient between X and Y, for example, you can use this following formula, or you can write it like that. Okay, so basically to calculate the correlation coefficient, you need the standard deviation of random variable X and also standard deviation of the other ones. So correlation related to the standard deviation of each part. But again, I want to note you about the limitation of this Pearson coefficient. So they have there is two limitations. First, it only considers and quantifies the effects on linear relationship. So even when the data set have more complex nonlinear relationships like quadratic functions, Pearson coefficient can only detect the linear correlation. And also, if there is an outlier, it can skew the measure of correlation. So the more outliers it have, the value of the correlation is becoming less and less accurate. So in this slide, it is like the final one. I want to notice you about that even you have all these descriptive statistics, you have the mean, you have the variance, and you have the correlation. We still need the other part of data exploration, which is visualization. Let's see why. So for example, in this picture, I have called Anscombe's quartet. I don't know how to spell it. So visualization should be the first step in understanding correlation before you decide stuff with your Pearson correlation. So visualization can help identify non-linear relationships and can show any outliers in the dataset. So in this Anscombe's quartet, it illustrates the limitation of relying only on the correlation coefficient to understand the data itself. So if you see these 4 pictures here, all of them has the same mean, has the same variance, and also have the same correlation. So those 3 values that we've explored before, they are the same, but as you can see here, they are pretty different graphs. One is looking like this, one is like, it's kind of correlated in a non-linear way. One is like super correlated, but there is an outlier, so that's just going up, but that's not about it. And one is like all the data is like collecting here, and there's one data apart, and again this line is, I don't know, become weird. So even though you have all those values, mu, sigma, and r, that doesn't mean that you can understand the data right away without visualization. So again, visualization should come first before you decide a lot of different stuff, detrimental stuff with mean, variance, and correlation. So in the next part, we will talk about the visualization, so stay tuned. See ya.